pentagonal prism of 30 mm base side and 50 mm axis is standing on HP on its base with one of the side of base is perpendicular to VP. So if I draw its front view and top view, its top view is going to be a pentagon, and in that pentagon one of the side is going to be perpendicular to XY line. So this side, let's say so this side is perpendicular to the vertical plane. In top view it is perpendicular to XY, that means it is perpendicular to vertical plane. It is a pentagonal prism, so it is going to have pentagon at the base, pentagon at the top. So every corner point has to be provided with the two names, one for the corner at the top and one for the corner at the bottom. So let's provide two names for the front view and two names for individual corner. Now project it for the front view. The axis height is 50 mm. So this distance is going to be 50 mm. This edge at the center, this is A dash, B dash, C dash, D dash, E dash, and for the base let's use the nomenclature 1 dash, 3 dash, 4 dash and 5 dash. Okay, now let's locate center of this pentagon. We need to locate the axis, and for that one first locate the center and then draw this center line which is going to represent the axis of the solid. Why do we need to locate the axis? Because the cutting plane is passing through midpoint of the axis and it is 45 degree inclined to the HP. So let's say this is the cutting plane. For cutting plane also it is going to be a center line and slightly thicker ends. Cutting plane is appearing in front view, so it is to be named as VT. Now this angle is 45 degree, that is given in the question. Now this cutting plane is intersecting the solid and it is intersecting all the 5 vertical edges of the solid. So this is the first intersection point. Over here it is intersecting two edges, B dash 2 dash as well as E dash 5 dash. Similarly over here there are two intersection point. One is on C dash 3 dash and next one is on D dash 4 dash. So let's say this is P dash, Q dash, R dash, S dash and T dash. So we have named those 5 points. So till this point this is section of the solids only. This is exactly the section of solids part. Now we are going to draw its developments. while drawing developments, the development of the solid, or to be specific, development of prism, it is going to be a rectangle. And when you are drawing a rectangle, we need two dimensions. One of the dimension is height and second dimension is width. Now to get that height, I have simply taken a reference of the top and bottom surface of the solids. This is height of the solid, so same dimension will be considered for development also. So we are done with the height. Second dimension, width. In case of prism, this solid is a pentagonal prism, so it is going to have 5 sides. Length of each side is 30 mm. So take that 30 mm in a compass, starting from this point, and locate the 5 number of sides. So whatever number of sides you have in your solid, exactly same number of sides to be drawn on development as well. So this is going to be a development of the solid. Provide nomenclature. Top surface, we are considering nomenclature A, B, C, D, E, and the last generator is going to be common generator. So generator, or over here it is edge. So the name that you have taken for the first edge, same name will be there for the last edge also. So this is first, second, third, fourth, fifth, and last one again going to be the 1. So A1 will be the first edge, similarly a last edge, because it is common for the two rectangular faces, AB12 and EA51. So once you have located those 5 rectangular faces, now transfer all the intersection point that you have got on specific edge. For example, let's take point P dash. It is on the edge A dash 1 dash. So transfer that point horizontally on the generator A1. This is the first generator A1 and last generator A1. So this is also point P, this is also point P. Similarly, second point Q dash T dash, it is on the generator B2 and E5. So project that point on B2 and E5. So this is on B2 point Q, and this is on E5 point T. Similarly, next RS, it is on C3 and D4. So this is on C3 point R, and this is D4 point S. Okay, so once you have projected all those points on those specific generators, this is a prism which has got a flat faces. So on that flat face, when you connect 2 points on 2 edges, those points are to be connected with a straight line. So connect all those points with a straight line. Sorry, this is to be connected over here, or let me erase it. Connect all the points in a sequence with a straight line. Okay, now in case of when you take section, observer your position will be above the solid. This is the cutting plane. The portion of the solid which is appearing in between observer and cutting plane, this is to be discarded, and portion remaining, or the portion below that cutting plane, this is the uh, remaining object, and this object is being developed over here. So below the cutting plane, the whole part is to be highlighted, because this is going to be our object. Similarly, these vertical edges till that cutting plane also to be highlighted, because these are the visible edges of the prism. So this black portion is basically a development of the this solid in present scenario. A cone of 50 mm base diameter and 70 mm axis is standing on its base on HP. So if you consider this as XY line, its top view is going to be a circle, and front view is going to be a rectangle. So before drawing that top view, let's split this circle into equal parts. So this is first division, second, third, fourth. Okay, just a second. Okay, so this is first division, second, third, fourth, fifth, sixth, seventh, and eighth division, and this is the apex O. Project all the points for the front view. Axis height is 70 mm, so locate that 70 mm and connect all the corner points with the base. Additionally, connect remaining generators also with the base points that you have projected. Name all the points. This is O dash, this is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and 8 dash. Okay. Now what is the condition for cutting plane? It is cut by a section plane 45 degree inclined to HP through base end of the end generator. So the cutting plane can pass through point 1 dash or 5 dash, because those two are the end generators, and base end is nothing but this point 1 or point 5. So let's take that point is 1 dash, and the cutting plane is passing through that point, and it is inclined at an angle of 45 degree. So this is our cutting plane. Cutting plane is nothing but a center line with alternative long and short dash, and with slightly thicker ends. cutting plane we are getting in front view, so it is to be named as VT. Now it is intersecting all the 8 generators that we have drawn, so we will get 8 intersection points. What are those intersection points? One point on O dash 1 dash, 2 points on O dash 2 dash, O dash 8 dash. Similarly, 2 points on O3 O7, 2 points on O4 O6, and 1 point on the rightmost generator, that is O dash 5 dash. So we have located those 8 points. Now till this point it is section of solids, and now we are going to draw its developments. To draw a development in case of cone, first locate the point O somewhere here and take some length. Now this length in case of cone is going to be this length, which is nothing but a slant height of the cone. You are not supposed to refer to this 70 mm, which is length of the axis. Axis length is this vertical distance, but we are going to refer to slant height of the cone. So that length you will get from the front view, so take that distance in a compass and mark it over here. After that, take O center and this point or length of this segment as a radius, and draw this sector. Draw this sector of the circle. Let me make it appear a little bit more realistic. Okay, now it is good. Okay, we know that the development of cone is going to be like this one as a sector of circle, and for that we need this theta. Now to calculate that value of theta, we have got relation theta is equal to R by L into 360. So solve, put R is radius of the base circle, that is the radius of the base circle, this is 25, so is equal to 25 divided by what is slant length that you will get from this sketch. That length you are supposed to put in here, multiplied by 360 degree, and you will get that value of the theta in terms of degrees. So once you get that value of theta, mark that theta over here and complete the sector. Now the next step that you are supposed to do, we have splitted this base circle into 8 equal parts, so this sector also to be splitted into same 8 equal parts. Okay, so whatever value theta that you get over here, divide it by 8 and you will get the value of single division, and then mark those divisions and split this sector into 8 equal parts. So let's say this is first, this is second, third, fourth, fifth, sixth, seventh, eighth, and first division. Similar to previous example, the first and last segment is going to be same common generator. So this is development of the cone. Now what we have done, we have taken section of this solid along this section plane, and after taking section we know that this upper part which is appearing in between observer and cutting plane is to be discarded, and remaining portion is to be drawn in development form. So to draw that development, we need to locate that every intersection point on same generator in this development. So let's take an example. This is point P dash. It is on the generator yes, it is on O dash 1 dash. It is at the base. I represented it slightly above, but we know that it is passing through base end of the generator, so it is passing through exactly at the corner. Okay, so on O dash 1 dash it is at the corner, so this is one of the point, and the same generator at the end also, this is other point. Okay, similarly second Q dash and R dash, it is on the generator O dash and O dash 2 dash and O dash 8 dash. Now while transferring the first point, that is P, we directly can take distance from O dash to that point and locate it on the development. But when it comes to locating other points, now see, there are 8 generators. Out of 8 generators, only generator O1 and O5 is true length in front view, because those two generators are parallel to XY line, which is nothing but parallel to vertical plane. So those two are going to be in true length in front view. That is, the generator at the leftmost O dash 1 dash is in true length, and generator at the rightmost O dash 5 dash is also in true length. But remaining all other generators are going to be representing reduced length. So in development, every generator is in true length. Those points are to be projected on generator which is in a true length. So transfer all the points horizontally on rightmost or leftmost generator, both are in true length. So for time being, I have projected all those intersection points on the leftmost generator which is in true length. Now let's say I am going to locate Q dash and R dash, so that I have projected on the this O dash 1 dash. Take distance from O dash to that point that you have projected, and go to the development, keep compass at O, and then intersect the generator O2 and O8. So this is that was the point P, that is also point P. This is point Q, and this is point R. Okay, similarly next S dash T dash, transfer that point horizontally on the leftmost generator, take distance of that point from O, go to development, keep compass at O, and intersect the generator O3 and O7, because that S dash and T dash is on the O3 and O7. So this is S and this is T. Next point U and V, it is on generator 4 and 6. Transfer that point first horizontally on the leftmost generator, take distance from the apex to that point, go to development, keep compass at O, and have intersection with the generator 4 and 6. So this is your point U and this is point V. Last point W, as I mentioned earlier, the rightmost generator is also indicating true length, so that need not to be transferred anywhere. So take distance of O dash to W, go to the development, keep compass at O dash, and have intersection with the generator O5. So that way you will get all the intersection point. Now this cone has a curved surface. So on that curved surface, whenever you try to connect any 2 points, those 2 points are to be connected with a freehand curve. So connect all these points with a freehand curve. Oh, sorry. What can we do? Not let to. Okay. This one we can do. This is fine. Sorry. So this is to be connected with a curve line. This software has function of auto straightening the line, so I am just trying to escape that function. Okay, so this is the curve. Now as I mentioned, this upper part is to be discarded and lower part is our object, so this remaining part is also to be highlighted. Okay, so the portion that is highlighted with this black color, this is the actual development of the given solid.